This digital multimeter basically does everything I need it to, and I bought an extra parts for it. Those will be linked in the description below, like button. But this digital multimeter is the one I use for all my engineering. We have a user manual. We have a temperature probe that will go inside of it. You have these two prongs, and then the actual temperature measuring part, which would be this metal tip right here. Also have two extra fuses, and then the multimeter itself. So there's a lot of functions with it. It has auto power off, you have these functions, you have the different units, you have your range. You can also use a flashlight, which it has up here. It seems to be an LED module. And then we also have a screen brightness, so you can turn the brightness of the screen on. You also have a live wire detection, so if you hold this up to any wire, you can tell if it has any voltage going through it or not. And then we also have these different states which you can measure: voltage, millivolts, we have resistance, diodes, capacitors, and more along here. We will have to change this. We can see that we have measurements down here with max 600 milliamps fused, and then we have max 20 amps fused, and this is shared with both of these. So depending on which you would want to change where these are plugged in. For me, I have the black one plugged in to the COM, and then the red one plugged into this as well, so that they can measure it. Now, on the back is where you're able to store your probes. There's a magnet, and there's a place for you to hang it as well, and there's also a kickstand. Behind this kickstand is where the batteries are going to go in here. Now that we've gone through this, can read the manual and look more about it. We have our general information. The digital multimeter is designed and manufactured in compliance, so that's the first thing. We have our safety information. Before opening this meter, the operator must observe all standard safety procedures. So we have safety procedures against electric shock, safety procedures against unintended use. To ensure our personal safety, please use the test lead that accompanies the multimeter before operating this meter, and ensure the test lead is flawless. So that is talking about the actual tips right here, the metal ones that are actually very sharp, so be careful not to poke yourself. You can put like adapters on here. I have alligator clips that you can use so it's easier to measure things, or little probes to get down deeper into little crevices, like little parts of the breadboard. Some safety considerations: when the meter is used in the vicinity of the equipment that produces strong electromagnetic interferences, the readings on the meter will grow unstable and even cause serious errors, so watch out for when it's in strong electromagnetic areas. We don't operate the meter or pen-shaped meter whose appliance is damaged. The safety function of the meter will become null if the meter is not operated properly. The meter must be operated with great care when working in the vicinity of an exposed conductor or bus line, so like live things. The meter is prohibited from being used in the vicinity of any explosive gas, vapor, or dust. That's probably just because it might interfere with the meter itself. The measurement must be made with correct input terminals and functions and within the allowable measure range. To prevent the meter from becoming damaged, the value to the input shall not exceed the extremes allowed by each measuring range. And the measuring range is given to us below right here. So if we use these two ports, we would have a max of 600 milliamps fuse, max of 20 amps. And the 20 amps is going to this part and this part. And then we have a max voltage as well here. And then we also have our grounding, so that's important to look at. When the meter has already been connected to the line being measured, the operator is prohibited from touching the input terminal that is not in service. When the voltage measure exceeds 60 VDC or 30 VDC, which is the valid value, the operator shall be careful enough to avoid electric shock, so that's on you. When making measurements with the test lead, place the fingers between its protective ring. And the protective ring, I think, is like this part right here. You want to make sure your fingers are behind it. When switching to another measuring range, be sure that the test lead has already been removed from the measured circuit. And you're measuring a different thing, you would want to remove it before you use this knob and change what it is. For all DC functions, to prevent potential electric shock as a result of incorrect reading, DC is direct current. Please first use AC functions to check the absence of any AC voltage. Alternating current, then select DC direct current voltage, measuring range equivalence to greater than for the AC voltage. Before the test on electric resistance, diode, capacitor, or continuity, the operator must cut off the power supply to the circuit being measured and discharge all high voltage capacitors within the circuit to be measured. So just let the capacitors sit for a while and let them slowly drain. The electric resistance measured or continuity test cannot be carried out in any live electrical circuit. So again, disconnecting. Before the current measurement, the operator must first examine the protective tube of the meter. Before connecting the meter to the circuit to be measured, the operator must first power off the aforesaid circuit. So before measuring, you want to power off anything. Before repairing TV sets or measuring power switching circuit, the operator must be careful enough to prevent high amplitude voltage impulse from damaging the meter. The meter uses a 4 by 1.5 AA batteries that must be correctly installed into the battery compartment. When a little battery symbol appears, the battery must be replaced immediately. The low level of a battery will result in incorrect reading of the meter, which is likely to bring electric shock or even personal injury to the operator. In measurement category 2, voltage in category 3, voltage shall not exceed 1000 volts and 600 volts respectively. Now, a normal wall outlet I think is like 120 volts, so if you're measuring that, should be good. The meter shall not be in service if its case or part of the case is dismantled, so make sure everything is well put together before using it. We have some safety symbols now. The safety symbol that appears on the meter's body and in its operation manual is the following. So we have a warning. It's an important safety symbol. The operator must consult this operational manual before using the meter. Unintended use may lead to damage on the device or its components. We have this little tilde, which is AC alternating current. We have a line with dots under it. That's DC direct current. We have AC DC, which is a line and then our tilde underneath it. We have a ground symbol, double insulation protection. We have a fuse, compliancy, high voltage warning, and then we have our over voltage protection. We also have another over voltage protection here. Now we're going to look at maintenance and practices for safety. The operator must first pull out the test lead when the meter's case is opened or the battery cover is dismantled, so make sure everything is disconnected from an actual live circuit. The designated replacement parts must be used at the moment of maintenance. The operator must cut off all relevant power supplies before operating the meter. At the same time, the operator must avoid damage to the meter's elements by ensuring that he himself doesn't carry any static. So you don't want to interfere with the results or anything. The meter can only be calibrated, repaired, or maintained by professionals. When the meter's case is open, the operator must understand the fact that the presence of some capacitance may promise the dangerous voltages even if the power supply to the meter is cut off. So everything has a little bit of parasitic capacitance, since parasitic capacitance can lead harm, so just be aware of that. The operator should stop using and maintaining the meter immediately if any abnormality is been noticed. The operator must see to it that the meter cannot be in service unless it is proved conforming. When the meter is left idle for a long period of time, the operator shall remove the battery and place it in a place free from high temperatures and humidity. So just like anything when you're using batteries, you're going to want to remove them if they're not being used for a long period of time so that it prevents like any corrosion or battery leakage. We have input protection measures now. The meter can sustain the maximum input voltage of 1000 DC or 750 AC at the moment of voltage measurement. The meter can sustain the AC voltage of less than 250 volts or equivalent voltage with the tests on frequency, electrical resistance, continuity, and diodes are carried out. So when we're measuring voltage, we can go up to 1000 DC, 750 AC, but when we're measuring anything like resistance, continuity, and diodes, we want our AC voltage to be less than 250. The protective tube is used for protection purposes for the wattage when our microamps and milliamp current measurements are carried out. Now we have a schematic diagram of our meter. The meter is a handheld digital multimeter with the function of displaying true RMS. It is a large screen LCD unit with backlight and illumination light functions so that the user can easily recognize readings. It is equipped with the function of overload protection and the indicator of battery under voltage. Either for professionals, factories, schools, enthusiasts, or household, it's an ideal multimeter function. So we have our schematic right here. 1 is our non-contact voltage detection area. 2 is the non-contact voltage indicator. So it will tell you, it'll also beep when I've used it. We have the non-contact voltage buzzer indicator light, which is part of the top housing here. We have our LCD screen, an infrared detection window, which is this fifth part, but this is only on the 28C. I have the 28B, and you can see which one you have on the box. It's marked in red. This one is the 28B that we're looking at. It doesn't have all of these right here, so we can skip over this, skip over this. We have backlight and flashlight. We have our rotary switch. We have our receptacles. That's going to be on 9, where we plug everything in. We have our frequency, which is going to be 10 up here. We have our function button, which is 11, be right here. We have our manual auto ranging switch. This is only for the one that we have, so that's going to be this 12th one right here, which is the range. We can change what range we're measuring in. We have 13, which is the 20 milliamp socket, 14, which is our milliamp socket, and the COM input socket. Now we have a description of the symbols and the display unit. We have our battery under voltage indicator, which is low battery, to prevent electrical shock or personal injury as a result of incorrect reading. We need to promptly replace the batteries. We have our auto power off indicator, so it should automatically turn itself off. We have a high voltage warning, negative input polarity indicator, AC, DC, continuity, diode, our automatic range measurement mode, data hold mode, unit of temperature, duty ratio, non-contact voltage, infrared remote detection, that's not on ours, and neither is the transistor magnification measurement. So those are only on the T28C. We have our table of units right here, and this is just converting. We have our milliamps, amperes, and all of those listed right there. We have a description of our function keys. So when we have our function hold, which is to the left of our multimeter, we short press the key to enter the function select keys, such as the following. We have our temperature, we have frequency, hertz or percentage that we can measure in. We have our ACV or ACA. This is only on the 28C, so we don't need to worry about that. If we press this key, the illumination one, for more than 2 seconds, the backlight and the illuminator indicator will be on. However, long pressing the key for more than 2 seconds will turn off the backlight and illumination indicator. If we don't press any key at all, the function will automatically be disenabled in 30 seconds. So if we turn it on, just like measure resistance right here, we're not measuring anything. If we press it, we'll turn the backlight on. If we press and hold it for 2 seconds, it turns the flashlight on. And then if we press it again, it turns them both off. If we just single press it, it turns the backlight on and off. For our 28B, the AC voltage or AC current position under AC voltage or AC current measurement state, we can press any key for this one right here to enter the AC hertz percentage measurement mode to change this. We have our range. It's automatic, but we also have a manual one where we can change the specific range. We have the description of our input socket, so our COM. All public input terminals to be measured are connected to test leads in the blank and public output. We have our measurements, diode measurements. We have our voltage, temperature, electric resistance, frequency, and duty ratio. We have our micro and milliamps, which is on the positive input terminal. And this is going to be with a red test lead that we connected to. And then we have the 20 amp positive input terminal, which is connected to a test lead in red as well. So the black one will usually stay here, and this red one will move around. This black one actually has a black circle on the multimeter that you plug it in, and this red one can switch between all the different ones. Our accessories are an operation manual, which is this. We have our test leads. We have our thermocouple, which is here, and then also these additional fuses. We have operational guidelines, which is kind of going over everything that we just covered. Measurement guidelines, which is going over how to measure. We have our electric resistance measurement, which tells us how to measure the resistance. We have our beep continuity, capacitor measurement, frequency measurement, so it's really just going more into depth on the measurement. Now we have current measurement, needs cut off from the circuit. The clamp meter is recommended for this. So if we have our load, which is any electrical appliance, we have our black and we have our red for the different probes that we have here. And we can see that we're putting them into here or here, depending on what we want to measure. And these can go into like an AC outlet, and this would represent both of these, or it can go into a battery terminal. Remember, red is always going to go into the positive, and the black is going to go into negative, because the black acts as ground, and the red is going to act as like the power. We have our current measurement here, and we have a warning. Do not attempt a measurement on the current in a circuit if the voltage between the open circuit voltage and the ground is over 250 volts. If the fuse is blown at the moment of measurement, you are likely to damage the meter or get yourself hurt. To avoid any damage to the meter or equipment to be measured, Do not attempt a current measurement unless you have examined the meter's protective tube. In attempting a measurement, you should use the correct input sockets, function position, and measuring ranges. So you gotta be careful to really double check everything. When a test lead is inserted into the current input socket, do not put the other end of the test lead in parallel connection with our circuit. Because voltage in parallel, it's just the same throughout, it's gonna be pretty big. The meter provides DC current measuring ranges, which it tells us here, and it provides AC current ranges, which tells us here. So page 9 is pretty important when you're looking at this. We don't need to worry about this transistor measurement. However, we do have some more information here that pertains to this. So we can skip over transistor measurement because that's only to the 28C, and so is the infrared signal detection, which is pretty cool though. We have technical parameters, and then we also have a precision indicator. So this is just going to tell us the DC voltage, frequency, electrical resistance, and more on how accurate it is. That's this page right here, and that's this page right here as well. After this, we have our meter maintenance, and this is the last part of the English section. We have all these different tabs for different languages, and it's just repeating the same information, just in a different language. So for meter maintenance, this section provides the basic information or maintenance, including the descriptions about replacements of protective tubes and batteries. We should not attempt meter maintenance unless we are experienced in maintenance and have read the information on calibration, performance tests, and maintenance. So probably for most people wouldn't want to do that. In general maintenance, to avoid any electrical shock or damage to the meter, do not attempt to clean the inside of the meter. We must remove the line connecting a test lead to the input signals, so we're going to want to remove these whenever we're maintaining it. So we could take both of these out, and they just look like this. We should regularly use damp cloth and a small quantity of detergent to clean the meter's shell. Don't use any abrasive or chemical solvents. The dirty or damp input socket may affect reading, so make sure everything is clean. We want to disenable the meter and put all the leads out of the input socket. Clean up any dirty substances or sockets. On the sockets, use a new cotton ball with a detergent or lubricant to clean each socket, because lubricant can prevent the socket vulnerable to dampness from pollution. Now we have our battery and fuse replacement. To avoid any electrical shock or personal injury as a result of incorrect reading, we should replace the batteries when we see the symbol appear, and we've seen this before. Only the designated fuse for 600 milliamps, 250 volts, 20 amps, or 250 volts, quick acting fuse should be used. To avoid the electric shock or personal injury, don't attempt to open the battery cover to replace the batteries unless everything has been powered off already and we've carried out our examination to test that the leads have been disconnected from the circuit to be measured. The batteries must be replaced by the following steps: cut off the power to the meter, put all leads out of our input sockets, which we've done so far. We're going to use a screwdriver to unscrew the bolts on the back. I think there's like 4, if not just 1. We're going to take off the battery cover, slide out the batteries or the damaged protective tubes, which would be like these, and make replacements with new batteries or a new protective casings. We'll remount the batteries and fix the bolts in place. And that's all for the manual for a professional digital multimeter, and this is the one that I use. A good multimeter is very important for computer engineering because you're going to want to use this a lot for everything that you do, from testing. Mostly I use just as resistors, but it's still a cool tool to have, and it's relatively inexpensive. Then you're going to have it for a long period of time. This is how I try to package my multimeter inside of its little case. So everything really fits in almost perfectly here. It's a little bit chunky with these, especially because I would like to leave everything plugged in. However, that doesn't really work. I might try to 3D print a case depending on how big this is. I'll have to measure it, but a more suitable case for something like this, because it still doesn't close all the way. With the actual casing that's around it, we can see that there's a protective rubber casing, which is nice because it'll protect it from falls or anything. Everything fits in here. I've actually never used these before. I want to try to use them. And the thing I was trying to find were the other adapters that I bought off of Amazon. Those will be in the description below the like button. But these alligator clips, I use them all the time when I'm measuring resistors. They just go onto the little terminals here once the casing is removed, and you can just open them and close them super easily. They come in these protective casing as well. They're rubber, so they're like an insulator. I don't use them though because they sit pretty deep inside and are not the easiest to use with them on. But with them off, they're super easy, and I actually prefer them than just having the regular leads when measuring like resistors or anything where I can easily just clamp onto it. But here's the case. again, I'm going to try to 3D print a one that fits it a little bit better, as well as all the accessories that I bought for it once I find them. But closing it up, everything fits in really nicely. Everything is held in here so I could take it if I needed to go somewhere. And that's it for the digital multimeter.